All right. So we have been looking at steady state error. I don't think I have ink in this one. So what I'll do is I'll use the red.
Do you need a black one, Dr. Simi? I've got a black
No, that's fine.
one. Would it be a little more visual than
Yeah.
Let me. I think I have a black one. No, there's a class one. That's fine. I'll just use this. Maybe when I don't have, I'll take it from here. So we looked at the basic definition of steady state error, right? It was limit as tends to 0 s e of s, correct? And this translated to limit as tends to 0 s r of s divided by 1 plus g of s. Okay? And what we derived was these steps would be limit as s tends to 0, 1 over 1 plus gs, E ramp and E parabola.
E ramp? Isn't E ramp 1 over s plus s of gs?
E ramp is what?
1 over s plus s of gs?
S will become 0.
Oh, that's right.
Okay.
Oh, I'm sorry.
I'm going to keep this like this.
We're about to do some example problems or something. We're about to do some example problems or something.
Sure, we looked at one example problem last time. What I'll do is I'll cover some more topic and give you another example. Okay? We need to look at system types. Okay? So the book has this. There are 3 types of system. Okay. And I'll give you an example.
Truncates into what happens. Say what happens. What the fuck is this?
Call sign will be dragon.
What you say? It's called something hardcore. It seems like the order system is just getting bigger. Oh wow.
It is. Right. So, but what you have to look at here is look at these terms. Okay. This term, and there's nothing here.
Wow, that's where the zero comes from.
Right. So if there is no, this is called in the Laplace transform or transfer function world, 1 over s is called a pure integration term. Okay. And similarly, s is called a pure differentiation term. Okay. So here, if you look at the first one, there is no pure integration term, right? You see that? Everybody sees it?
Yes.
Here there is one. You understand?
Yes, sir.
Here there are two. For example, this could be written as 1 over s into,
All of that.
let's say, g 1 of s, right? And this could be 1 over s g 2 of s. You see, this thing corresponds to this. You get it? Okay. So you can say that g of s is 1 over s g1 of s, where 1 over s can be taken out. So this is a type 1 system. There is nothing like that here. This is a type 0 system. This is, so if you look at this, again, okay, it can be written as, 1 over s squared. There are two pure integration terms. You got it? Does that make sense?
Yes.
The thing about this is, if you recognize the type of a system, okay, if you recognize a type of the system, what you'll see is, think about this. E step E ramp E parabola, and you have type 1, type 2, type 3. Alright?
So it only applies to those? Oh wait, so you only go up to type 3, that's it?
Sorry, not type 3. This type 0, right? Type 1, type 2. Only up to type 2, yes. 0, 1. Guys, pay attention here. Let him do whatever he's doing. Alright. This is finite. Okay? Infinity. And you can look up this in your last class. We did an example.
Sure.
Okay. So here it is. Zero, finite, infinity. 0, 0.
What does that mean?
Yeah. Take a picture of this. You will need these. So what I'm doing is I'm trying to give you these notes such that you can bring all these copies to your exam and use them as your formula sheet.
What does this mean? What does this mean?
I'll talk about it.
Okay.
Did you take a picture?
I wrote it down.
Shall I erase it?
Hang on. Sorry, I'm trying to make a connection,
Yeah.
but I don't.
Do you want it?
Yeah, I think it's in it. Trying to find the notes. I would try to make a connection, but I'm being recorded right now, and I don't want to look really stupid on YouTube.
So I'm going to erase this for a minute, okay? I'm going to erase this side and show you what it means. Alright. Take the first system for example. Okay. This one. This is a type 0 system, right?
Yes.
So each step of infinity, which means the steady state error as per the definition is limit s tends to 0, right? 1 over
1 plus G of
1
S.
plus
G of S.
s g of s, right?
G of S. For step,
Hmm.
S G of S would be ramp.
Yeah, correct. So you have 500, right? Look at that. Multiplied by 2, multiplied by 5, divided by 8
so you
into
go 8 times 10 times 2.
10 times 2.
So we took the S out.
We took, because essentially what I'm trying to do is,
S is 0. Got it.
yeah, your limit, right? So this is going to erase, correct?
Mm-hmm.
Now we tend to.
So you see this as finite, right? It is some finite value.
Yes.
You see it? This is something like 1 over, let's say 1 plus 5,000 divided by
It's 10 over 1's.
right?
Oh.
16
So we're,
2
Looks a lot like a matrix that we played with earlier in the semester.
4 12 5. Okay, so it is 1 over 1 plus 125 over 4, right?
Yes.
Which is equal to
4
over 129. You with me?
You want the decimal form or no?
That's fine. You can put it in decimal form as well. But you see it as finite, right? You see it as finite for system type 0.
So
Now let's look at E ramp, okay? And you'll understand what it means by infinite.
Dr. Sandy.
Hmm.
So would that finite value be, so for the E step and E ramp, would that value be the same? For
It is not same, it is some finite value.
But okay, so they wouldn't be okay.
Okay. But if you look at E ramp, by definition, what is E ramp?
E ramp is
Just
1 over
SGOS.
S
GOS.
G of S, right? So
Yes.
you have
I'll probably look it up.
Like going the whole way and make it out or something.
did we miss something here?
So what you want to see something? Two guys making it.
Okay, so then it'd be 500 times 2 times. Wait, wouldn't it
He's
be?
trying to figure something out first.
Okay. So it will be 500, okay, into
2,
2 into
5,
5,
6, and 6,
8, 10,
10, and 2.
2, right?
Dr. Sunday,
Ah.
isn't it supposed to be 500 into 2, 5, and 6?
No, we are still talking about type 0.
Oh, okay. Oh, you're trying to explain to us why it's 0. Okay, got it.
But if S is 0, then you have to do all that.
Right. So what's going to happen is,
It's going to be 0 anyway.
right? You see it?
Yes.
So here, this is 1 over 0, which is equal to
0. Or infinity, sir.
B. All of you get this wrong. I have mentioned this 100 times. Any number over 0 is infinity. Any number over infinity is 0. You get it?
Yes, sir.
0 over 0. Undefined. No. Infinity over 0. Undefined. Infinity over infinity. Undefined.
Because you okay. that makes sense.
0 over infinity. Undefined.
I thought a number over 0 was undefined.
You can't.
Why?
You can't define. I don't think about it though. You can't define something out of nothing.
Then it can't be defined. Okay, I don't think
Only
it's-
these
Okay.
two are defined.
Okay,
Okay?
I'm trying to use because it can't be infinite.
Because what you're doing is I have given you calculation for TP and percentage overshoot.
Right.
You have it clearly, the calculation clearly comes out to be infinity or 0, and you mention that as undefined. And this, I have been stressing this right from you take my class, any of my classes. It's not difficult to understand. Okay? So any number over 0 is infinity. Any number over infinity is 0. Alright?
Sure.
And keep in mind, 0 and infinity are concepts. They are not necessarily numbers. Does that make sense? Okay. So here, in fact, I think it goes like this.
How's infinity over 0 equals 0?
Now, this is undefined.
Oh, okay.
All these are undefined.
I thought that was 0 right there.
You got it? Because 0 is 0 over 0. There is no 0 over 0. That's the reason it is undefined. Don't tell me it is 0. and you will look very, very. It will reflect very poorly on you when if you go out and do this. This is not even high school. This is middle school mathematics. And you guys keep on saying this. It actually looks very stupid. I'm telling you. It reflects very poorly on your knowledge. Somehow memorize this and understand this. This is not a difficult concept to understand. If you think about 0 and infinity as concepts, 0 is not a number.
Okay.
What happens when you divide a number by a very, very, very small number? What is this number?
It'd be infinite, but that'd be like in a limit situation.
If there is a number, you divide it by a very, very small number. What is this?
It would be infinite. It'd be infinitely small. I mean, you call it 0, but
If there is a number, you divide it by a very, very, very small number.
Don't get a very, very big number.
Very, very big number.
I'm sure.
Do you get it? If there is a number, you divide it by a very, very, very big number. What do you get?
Very small number.
Very, very, very small number. Not undefined.
No. I'm talking about the first one. That's what my calculator said. But I couldn't check that.
If there is a number, you divide it by a very, very small number. What do you get here?
You just
You asking the same question again?
Hmm.
Oh, yeah, it's a big number.
Very, very big number. Very, very big number is what? Is kind of infinity. Okay, if you have a number and you divide it by a very, very big number,
It's very small,
you get a very, very small number. Very, very small number is
close to 0.
close to 0. Right on. If there is very, very small number and very, very small number, if that very, very small number or very small number is not, you don't know what that number is, you don't know what the answer is. Try to get this concept in your head, please, because I have seen this mistake being repeated again and again, time and again. You did that with TP, you did that with percentage overshoot. You understand? If you did your arithmetic right, and if you understood this concept, percentage overshoot and TP should not have been an issue. Of course, you can look at the concept itself, the understanding of these various second order systems, and say, if it is a underdamped system, what is TP?
Time peak. Peak time, sorry. That's what you're asking, right? So it's peak time? No, you're talking about something else. Sorry.
Any second order system, TP is time, peak time. If it is a overdamped system, what is TP?
What is it?
Oh, it's gonna be constant. Or you asking for like an undefined infinity or 0.
I get it mixed up. It's either 0 or.
If it is a overdamped system,
It's gonna be
what is
constant.
the percentage overshoot?
It's
0.
Yeah. Then what is a TP?
there is none.
Undefined.
Not undefined. Infinite. Don't say undefined.
Then infinite.
Infinite. Undefined and infinite are not the same. Please get this out of your head. Undefined and infinite are not the same. Say it 100 times before you go to bed, and say it 100 times when you wake up. This will look very bad on your part. It's very, very basic understanding of mathematics. Okay, especially if you are going to be a spacecraft engineer. Don't go by the calculator. Calculator does not understand mathematics. For a calculator, 0 means 0. There is no 0 out there. What is 0?
0.
What do you mean 0?
No, basic math. 0 is 0.
You have to, huh?
Nothing.
Where is there nothing?
Space.
0 could be the origin.
0
could be the origin. 0 is
In reality, where is 0?
Nowhere.
Oh, everywhere.
Huh? That's exactly what you have to look at, okay? It's infinite and it's zero at the same time. Alright? There is no zero as such. Is there a zero atmosphere anywhere?
Maybe.
Huh?
I said maybe. I mean, we don't know what's all in the space.
Can you reach, is there an absolute zero
You're talking about like in terms of
temperature?
Yeah.
Can you ever reach absolute zero?
No.
But
Not absolutely.
absolute.
Absolute zero, it's almost impossible.
Yeah, it's not almost, it's impossible.
Uh,
You cannot reach absolute zero, 0 Kelvin, you cannot reach there.
I wouldn't say anything impossible.
Torius is an optimist. He believes
It's
anything's
physics, it's not about being optimist or religious about it.
possible.
It's physically impossible.
Don't tell me, tell him. I know it's impossible.
It's not a possibility or impossibility. It's physically it's impossible. Physics does not allow you to create energy. Okay, when you are reaching absolute zero, you have to create energy. There is no way to create energy.
Physics can be redefined sometimes.
No, physics cannot be redefined. Our understanding of physics changes, but we cannot redefine physics. Okay, just because
Or you can add it to it.
they are not traffic laws, right? You experience something and let's say you start re-establishing traffic laws. Physics is what exists in nature. That is our understanding. Our understanding will change.
Yeah, our interpretation.
Right.
of nature.
Our understanding, not just interpretation, but our understanding itself.
Right, and our understanding can-
As we go deeper and deeper, our understanding will get better and better. Alright? But for example, do you know that energy is conserved?
Yes.
Will that ever change?
Like, obviously.
Can you say a space can be occupied by two matters at the same time, any given space? That's physics, okay? Will that ever change?
I mean, from our point of view, thinking right now,
Hmm.
no. That would
That's
not
what. So
change.
there are some established concepts in physics. Now you also understand this. Unless you get there, you cannot claim that it might change. You get there, you prove it. I'll come to you and say, Torius, you are.
He's foreshadowing right now, Dr. Sunny. He's letting you know.
I'll follow you. Okay.
You follow me.
He's
I'll say undefined is Torius or defined is. But until that, we have to follow what has been established, what has been. Okay. Until we get there, we don't want to. We go by what we know, right? What has been established and whatever has been repeatedly proved. Okay. So there is no zero, there is no infinite. Everything is between zero and infinite. All right. So here you get this.
See.
All right. So what is E?
Parabolic.
Mm-hmm.
1 over S squared.
I'd be 1
S squared
over.
GS.
So it's again going to be
0, 1 over.
I don't think that's parabolic.
Yes.
I've changed this. Okay, please rewrite this.
Wouldn't it? Wait.
Oh, yeah, you did.
Oh, no, you're right. Sorry, I made a mistake. Or misread something. It'd be 0. Or, excuse me, infinity.
Okay. So this is for type 0. All right. Is this clear? And this is your example as well, Julian.
Yes, sir.
Okay.
I got you.
So you have to. Now you cannot bring examples to the exam, but create your formula sheet on what I'm trying to give you.
He said that we were using this one.
Okay. This table is very crucial for your formula sheet.
Yes.
Okay. The rows and columns are flipped in the textbook.
So
Okay.
because we got this
Hmm.
on the test, do we have to still solve it? Like since we have to.
If you recognize the system, you can write.
Okay.
Yeah, you don't have to solve it.
Okay.
If you recognize, that's what I'm saying. If you recognize the system as type 0, type 1 or type 2,
Okay.
Then you can just.
you can just write, yeah.
Okay.
Alright, now we'll look at type
1.
1, okay? Shall I erase this again?
Yeah, you
Yeah,
can raise the
that's-
left side again.
What I'm going to do is I'm just going to change this, okay, and make it type 1 here, right? How is this going to change? It's going to be 1 over 1 plus 500, 2 into 5 into
6.
6, right? What is here?
Should that be S plus? Well, yeah. Oh, it's 1 over S.
No, it's again.
Just the step equation formula. Is it going to be 1 over S or is it S plus all of that?
Shouldn't there be
The equations? Yeah.
What is the equation? Limit. So the equation itself is not dependent on its limit of s tends to 0.
Dr. Sunny, so it'd just be 1 over S. There wouldn't be a plus,
Is this what it is, right?
but it's a type.
Is this what it is?
No. Step is, or so. Oh crap! I was gonna ramp. Oops.
This is what it is, right?
Step is.
Yes, that's right. It's gonna be 1 plus G of S.
Yeah.
1 over 1 plus G of S. Yes.
Okay.
But if we apply the type 1 rule,
Okay, so it'd be 1 over S plus S of G of times G of S.
why wouldn't you change the 1 to an S?
You don't have to change anything. You
Oh,
just
so
have to
we're not-
substitute g of s.
Okay.
I'm saying it's 1 over S plus S times G of S.
Is this s times g of s?
No, for step, no. It's 1 plus G of S. That's the equation.
What are you saying, Anthony? You're giving wrong information.
I'm saying it's.
He said what he thinks the final answer is going to be. That's what
Oh
he
wait,
said.
you not. Okay, I see what I did wrong.
This is what it is.
Yes.
Okay.
Yes.
Or when you solve for this,
Yeah, you're right, Julian. I was like a little ahead.
it will be
1 over 1 plus 500 times 2 times 5 times 6
it will be
times 2 times 5 times 6 over times 10 times 2.
and please learn to solve this. Guys, pay attention here. I need you to learn how to solve this. Many of you don't know how to solve this. Okay. This becomes 1 over 1 plus. What is this value?
Infinity.
Huh?
Infinity.
Everybody gets that?
And then in turn it becomes 0.
Yeah, it will be 1 over infinity plus 1 is what?
Infinity.
Infinity.
Which is closer to 0.
You see what I'm saying?
Where you get
Because infinity is a concept, infinity plus infinity is also infinity.
What's your question,
So I
Taurus?
know what's some fake
Hmm?
Taurus, what is your question?
Where you getting the 0 from? From the type 1 relationship?
Yeah, this is type 1, right?
You saying S goes to 0?
Yeah.
So here I substitute this, okay?
Right, I
Yes.
get that.
So if 500, 2, 5,
5,
6, 0, 8, 10, 0, 8, 10, 2.
Why don't you do that for the limit? Got you.
That was a type 0 system. Okay. So this is 0, right? You see? Now, type 1, 0.
So,
So here,
like I said, so our S in this case in type 1 doesn't affect our function or affect our system.
this is RS here means 1 over S. We have derived it. Okay. And that's what is going to be critical. I am going to give you, just find the steady state error of the given system. You have to identify for which of these. So if I give you this system, type 1 system, right? Only one of them is finite. You understand?
Mm.
You have to recognize that, and you have to use the appropriate formula.
Yes.
Other two will either be 0 or infinite. Okay, so here E ramp is what?
Is 1 over S G of S.
It is 1 over
S, G of S.
S into, you have 500, right? 2,
5 and 6.
5,
6.
6 divided by S into 8,
10, 2.
10, 2. So this cancels.
Mm.
Okay, so now this becomes finite.
That S was already part of type 1, but the ramp equation already has an S in it itself. So that's where it is.
So ramp formula is what?
1 over S G of S.
Limit as S tends to 0, 1 over S into G of S.
So we're at constant.
Okay, so this is that S and this is the G of S. Alright?
260, 500, 30,000.
Okay. I just want you to know that this is finite. Okay. You can calculate whatever the value is. Similarly, E,
Well, I thought if S goes to 0, then those two go to 0.
no, it cancels.
Yeah, but they potentially go to 0 too, though. Why don't you put the limit right there then? Why would you put the limit right there then?
It cancels stories.
Did you do S over S? So like 0 over 0?
It is not 0 over 0. If it cancels, then see,
Are
what
you-
happens is,
You're saying you're canceling out before you apply the limit.
yes,
Okay.
that's how the limit works. Okay,
So
if
you didn't do the limit, you just did that.
no, I did the limit. First, if you apply, so look at this, okay. Even before you apply the limit, this is how it turns out. This is the formula, right? You understand? So if I solve for this limit still stays here, okay? It will be 1 over S into 500 S plus 2 S plus 5 S plus 6 divided by S into
S plus 8,
S plus 8
S plus 10, and S
S
plus 2.
plus 2, right? And this cancels. And then I apply my limit.
Okay.
You got it?
Yeah.
If you apply your limit ahead of time, see then here what does this become if you apply it ahead of time?
It's going to be infinity.
Yeah. You got it?
Which is wrong.
You don't apply the limit before you solve the equation itself. Alright, so this becomes again finite.
So
Last is
parabola.
parabolic.
So that's 1 over S squared G of S.
So here it becomes, I'm going to just,
You should have an S.
again I'm going to solve this, okay? It's going to be 1 over S square, right? This would be
500
500
to
S plus 2
oh, sorry,
S plus 5 S plus
6
6 divided by
S
S into S plus 8 S plus 10 S plus 2. So 1 S cancels with this.
1 S
This becomes 1 over 0
times 500.
times whatever number. So this becomes
Nice.
Nice.
okay. So infinity 0 finite. You can see that, right? Infinity. Sorry. 0 finite infinity. And then the final one is you can verify that 0 0 finite.
Dr. Sunday, you mentioned that in the textbook, the rows and columns are switched.
Right.
Is that just based off of the
The
way
table.
you have it set it up?
Yeah, the table rows and columns are switched. You
Okay.
can look at that, but you have to understand that if you have this information, you should be able to solve, and it should not make a difference for you because you have not seen the textbook. Okay, if you've seen the textbook ahead of time, maybe it would be confusing, but it's not. Okay, this is the first time you're seeing, and this could be the table you will refer in your exam. All right.
And you'll just want us to make the table. Is it-
Right.
we should know that there's.
You cannot bring the notes as they are for your exam. If you want a formula sheet, create a formula sheet only with the formulas. No examples. You cannot just get notes or copies of your screenshots or pictures.
But it's fine to have the table on there.
You can have table, you can have formulas, all of that. Right. So I'll give you one example. And this is good. This is going to be a tricky example.
Nothing's too tricky for this class. As in group students.
As a team.
As a team. That includes you, Dr. Sunday.
Hmm?
That includes you too, Dr. Sunday. You're a part of this team.
I agree with you.
Sorry.
I agree with you.
Finally finding some common ground.
We are a team from the beginning. See, that's the reason I'm trying to drag you so that,
You're our team captain and Dr. Khan's like our coach.
right, so we don't get left behind.
Okay.
So what?
Whenever I feel I've gone ahead, then I come back and try to get you guys again.
I'm glad we've got you as a fearless leader, Dr. Sunday.
Are they?
I'm glad we've got you as our fearless leader.
I have option 2 or 3 p.m. option.
When will the,
I have
I'm just curious, when will the next assignment be up on Blackboard?
I'll try to put it this week so that you are prepared for exam next week. So next week we'll have your exam, okay? Next Thursday, I think, because I need to give you at least one more exam
Okay.
before you take the final.
One more exam after this coming one?
Yeah, because
Okay, I was just making sure.
many of you need to drop your first exam, right?
Yes.
Wednesday and Thursday.
Do you have our last, the exams you give out Thursday?
Yeah, not here, but in my office.
Okay.
I've graded your exams.
He's available, I think, from 10 to 1 and then from 3 to 6 or something.
Is the final going to contain any more information than we already went over or no?
Final will be comprehensive.
No, but I'm saying that we're going to learn something more or no?
Of course, you're going to learn much more.
I was basically trying to see if we could just push it back to Tuesday, the 9th. I was trying to see if we could push it to the 9th.
But see, you need one more exam, right? Your final is going to be right around see if have you applied, how many of you all have applied for graduation?
I have.
Or it's like I got another year.
Dorius is going to make sure he passes my course, only then he's going to apply.
Yeah. That's
Okay.
I'm
How many of you all have applied for graduation? How many of you all are going to think that you graduate? You're going to graduate.
I know I'm
I'll
graduating.
go for it.
I'm graduating. I'm
In
not leaving.
December.
You don't know.
I know I'm graduating.
I only have one more year.
Huh?
I can't not graduate in a year.
Alright,
Yeah,
I'm a
so,
graduate or I'm put out, so.
Yeah.
so you may think you are going to graduate, which is
Is everyone taking the final at the same
No one's
time?
telling me.
I said, since we're all in the senior class, aren't we all taking the final at the same time? Or no?
yeah, you can take all of you can take the final at the same time. I think it'll be better for you guys, right?
What is that? The senior finals are the 24th and 29th of April.
Oh, that's hot. Let's do it.
24th to the 29th?
Because this
Oh,
one
that's
was
a
supposed to
long
be
one.
20.
This one I sent you. But I don't think we're calling the page.
Come on, man, I'm just letting you know like it is.
Oh shit. That was
Sorry, there.
Hunter, that was
Arrow.
You been all the classes I've been in?
Yes.
Hunter, that was good. I'll start sending you some. That's just what we're gonna do. We're gonna start sending you some appropriate stuff.
Awesome.
I mean appropriate. Nothing but gentlemanly discussions going on.
So did y'all just put the flag on this one? Where it is?
I think it's
No, it's the
flag
flag
on
on that
this one.
side.
That's right.
Don't put
And
the flag
then
on that side.
don't tread on the other side. Because that was
So our
the
test
original-
is our test is gonna be on steady state.
Yeah.
Your next test is going to be on steady state error. Yes.
What chapter is this? 7?
Chapter 7. Yes. All right. So I'm going to give you a broad example, and I'm going to give you a tricky example. I'm going to solve this for you.
Not without the help of us.
Huh?
Not without the help of us.
Yes. Please be attentive because a similar example will appear on your exam. Okay.
And then worse test at homework. And then it will appear on the
So I'm going to say find the steady state errors. And the question is it's very precise. I'm not going to give you what is the input, any of those. Okay. Error of G of S equal to
I can't see what you're looking at.
You knew about John semester, right?
You did?
And none of them, we couldn't use any of them today. So,
Where were they?
I don't know, people been letting people borrow it.
I mean, we haven't used them all semester. That's the first time. It's the first one PC.
okay. If you have the table on you, right, or if you have the formulas on you, what you're going to say is, what is what is the system type here?
type 2.
Type
No,
one.
it's type 1.
It's type 2.
It's type 1.
It's squared.
It's type
Type one.
1
It's
and
type
type
one.
2.
It's type 2 because it's
It
S
cannot
squared.
be type 1 and
It's type 2 because it's S squared.
Just because it says square doesn't mean it's.
Yes, it does.
Is that true?
Alright, then tickle is type 2.
If you
It's type 2.
Why can't it be type 1, Dr. Simon? Let's
Type 3.
there is no type 3.
What?
What?
That's all the BS.
and this is what is the tricky part, okay?
Oh, is it because we can't take like a 1S out of all of them?
What is this? S square plus 8s, right?
Yeah, it's because we can't take an S out of all of
Okay.
Copy.
it. Alright.
It's actually type 1, okay? But I'm going to justify why it is type 1. Try to understand why I said type 2.
It's type 1. It's type 1.
Plus,
Thank you, Dr. Sunday.
I was just shooting from the hip and everything and stuff like this.
Hey, we got class.
So
Oh,
here
you
it is-
right.
Come on, Josh. Come in class. You late.
you have S2s square, right? It is actually type 0, okay?
Julian.
Plus 10s plus 28. Can you take s out of this? 1 over s.
No,
No.
you can take a 2 out of it, break it apart, and then take it.
What I'm asking you is a
No,
simple question.
no,
Can you
yeah.
take s or s square out of it?
No.
No.
It's a type 0 system. You see why I'm saying it's type 0?
It is.
Don't go by this.
28 over
Okay.
S.
All s has to come out of all of the denominator. Okay?
Okay, alright.
So here now you know what E step is, right?
It's the easy problem.
E step is, according to table, finite. Okay. E ramp is what?
Change. Wait, no, I can't remember.
Infinity. Alright.
That's type 0.
Because this is type 0. And E parabola is
Infinity.
also infinity. But you need to calculate this. You need to compute this. You don't need to compute infinity, right? But you need to compute this. This would be
Oh, Dr. Sunday.
Hmm.
That was gonna be my next question I was gonna ask you. How when we're given our system or function, how do we now then know if it's a step, ramp, or parabolic?
You can look at this. So E ramp, if I ask you for a steady state error, all these values, knowing the type, you will know, you only have to calculate one of these.
If you
No, I'm saying like how do you like know which one like to pick to try to see if it is? You know what I'm saying?
you have to calculate all.
Table. So refer back to the table. If you know the type, that's the reason it's critical that you identify the type of the system. If it is for each type, you need to only calculate one of them, and that table will tell you which one to calculate.
Mm-hmm.
But if you get your system type incorrect, your entire thing is wrong. You don't get any points.
Mm-hmm.
You understand?
Mm-hmm.
It's either hit or miss.
We have a lot of those.
All right. So the formula is limit s tends to 0. 1 over 1 plus g of s. Right. This would be 1 over 1 plus 450 into
S plus 8
8
or 8, sorry, and then
divided by 28. Okay. Does that make sense?
Yes.
Oh.
You need to compute that and tell me E step. Okay. This is one type of problem I'm going to give you. Alright. There's another type of problem I gave you last class. Go back and check that. Where you're given the system and you're given, this is all for unit step, unit ramp, unit parabola, steady state error. It may not be unit functions. So last time I gave you the step input was 5 u of t. You remember? Go back and check your notes. The ramp input was 5 t u of t. That is not a unit, that is 5 units. U of t is 1 unit, which becomes unit step input. Okay, these formulas are for unit step.
You want the final answer?
Hmm?
You want the final answer?
Right.
It's 0.0077.
That is a steady state error. Okay. Okay. And these are very critical. I'm going to ask you this. You remember?
Yeah.
Oh, yeah. Like H for S and G for S
Yeah.
and C for S and
Unity feedback. This is cascade, parallel, feedback. Alright, so you may be given, all these formulas are for unity feedback systems. But you may be given a problem where it is not a unity feedback system, where you need to calculate the equivalent feedback system before you calculate the steady state error. Okay? I will assign the homework, I'll try to assign it today itself, so you have time at least until next Tuesday. and you can come back and do the take the exam on Thursday.
That's the 4th, by the way.
Thursday is the 4th, right?
April 4th.
Dr. Sunday, can I take mine on Wednesday because on the 4th we leave for Gettysburg. What's that?